Hello. Today's video I'd like to examine a little bit of some curve sketching techniques from an old IB test prompt. This one's relatively recent, but this is going to involve the quotient rule. As we can see here, we're supposed to find a maximum and an inflection point for a function that is a quotient of natural log and x. So first thing they asked you to do was to show that the derivative is equal to this. So I'm just basically going to ignore what I'm supposed to show and just find the derivative. That advice, whenever IB asks you to show something, they're going to give you the answer. A lot of students will make the mistake of using the answer as somehow a target. I suggest you use the question, find the derivative, and just take the derivative with your eyes closed, so to speak, and then make sure that they actually match at the end. That way, the answer won't be influencing your work, and sometimes people can make some logical errors that way. So, a reminder of the quotient rule would be the ho times the derivative of the high minus high times the derivative of the ho all over ho. And we have x times the derivative of the natural log of x, which requires 1 over x because God said so. We have good reasons for that, but we'll explore that more later. And then the natural log of x times the derivative of x is 1, so we just get the natural log of x times 1 over x squared. And then 1 over x times x is 1, so we get 1 subtract natural log of x all over x squared. And that exactly matches what I'm supposed to show. So it's all good. Next part of the question is asking for the coordinates of b at which the curve reaches its maximum value. So basically, the slope of the tangent line at b is going to be 0, which is a maximum value because we're going to continue to go down from there, apparently. And they already told us it's a maximum, so that's a little beneficial. We don't have to verify or classify the type of stationary point we get. So to find the max, we need to set the first derivative equal to 0. Because the first derivative is a quotient, all I need is the numerator to be 0, and the whole fraction will equal 0. So we're good if we just find out when 1 minus the natural log of x equals 0. In other words, what does it take for the natural log to equal 1? And hopefully you know that if x were e, the natural log of e is equal to 1. When x is equal to e, then we're going to be at point b, which is our maximum. But it said find the coordinates of b, so I'm going to go back to my original function, substitute in e, and get 1 divided by e as the y value. So you can see it's a very small number, which is why the graph is, even without a scale, you can see it doesn't go very high in the positive realm. So the maximum point is at e, comma 1 over e, or about 0.36. And I know that from reading the problem, I'm going to have inflection points here. So it's worthwhile just to remind yourself that if they didn't tell you it was a maximum already, that you would have to classify. And the quickest way, if you can take the second derivative to classify, is to find the second derivative and evaluate it at your stationary point, and whether it's positive or negative is going to determine whether you have a minimum or maximum. Hi. So anyway, just doing the second derivative test is not required in this specific case, but it's worth mentioning. And right here we have the second derivative, which we're going to use for part C anyway. So it wasn't a painful process here. I need to use it. So in part C, it is asking for the coordinates of the inflection point. So they already told us it's inflection, and we know where it is. It's going to be a bigger number than 1, or a bigger number than e. I know that off the bat. So I have the second derivative, thank goodness. I did all that work. And now I can use that second derivative. And again, inflection occurs when we have 0 second derivative. Likely it occurs there. So in order to get the second derivative equal to 0, I just need the numerator to equal 0. And be careful here, this is a factoring situation because we have an x in both terms. We could divide both sides by x, but then we would eliminate a possible solution. In this case, it won't be a problem, but it's worth remembering the proper way to solve using the zero product rule. So here, either x equals 0, which, again, this function does not have 0 as part of its domain, so we're going to cut it out. But we can take the 2 times the natural log of x minus 3 equals 0, which means the natural log of x is 3 halves, which means x is the square root of e cubed. I'm skipping some steps there, hoping your log skills are good. Nonetheless, we've got the function evaluated at e to the 3 halves. This is to find the coordinates, because again, it's looking for the coordinates of point C. I put that back into the original function. That's e to the 3 halves power, and I get 3 halves. So this is where the 3 halves is. E, natural log of e to the 3 halves is 3 halves, and then the square root of e cubed is e to the 3 halves as well. So that represents the y value for the coordinates of the inflection point. And it's given that it's inflection, so I don't have to classify or test that it's inflection. You know, actually, I don't even think we would have had to in that case, so please forgive me. All right, last part was asking about finding the equation of the tangent to the graph. It says basically the graph of y equals f of x crosses the x-axis at point A, so they labeled that for us, and then it said find the equation of the tangent to the graph of f at the point A. So this is some pretty rudimentary stuff. We have the first derivative already, and A is at the point, by the way, 1, 0, which should be straightforward, and we take f prime of x and evaluate f prime of 1 and establish that f prime of 1 is 1. So the slope of that tangent line is going to be 1. Point on the tangent line is 1, 0, so it's a pretty stinking easy equation to make, y equals x minus 1. And in case there's any doubt, we can actually find the stationary point, the inflection point, and the tangent line in Desmos. We enter all that stuff in by hand and make sure that it matches the graph that was shown to us. Do all that, and we'll be good math students. Thanks for watching.